let me tell you guys that the answer to this right here is... Okay, let's do some math for fun. Here I have this double summation for you guys. And whenever we have a double summation, be sure we do this part first and then that one. So first we have the sum as n goes from 1 to m, and then we have 1 over 2 to the m plus n's power. Do however you want right here. And then we do the sum as m goes from 1 to infinity. Or you can try to change the order of a double summation. But anyway, I'll leave that to you guys. At the moment though, please pause the video and try this first. Okay, let me tell you guys that the answer to this right here is 2/3. You guys can leave a comment down below, let me know if you just do this right here as how it is, or you change the order of the double summation. I think it's possible to do this inside out as how it is, but I will leave that to you guys. I will actually like to show you guys how to change the order of a double summation because it's really cool, just like how you change the order of a double integral. So here we go. But my prep word is I will change the color first. And for the 1 over 2 to the m plus n's power, it's pretty nice because we can break it apart nicely, right? This is the same as 2 to the m times 2 to the n in the denominator. So we can write this down as 1 over 2 to the m times 1 over 2 to the n. So this is pretty nice. And of course, I will just put this down right here. Now, as I said, let's change the order of the double summation. In that case though, I want to have the red summation go first. And then the summation in black like this, right? Now, you have to do this one carefully. Do not just put down 1 to m and then 1 to infinity. Do not just write down these numbers and these limits right there as how they are. No. Let me tell you guys what the answer is first. When n goes from 1 to m and then m goes from 1 to infinity, when you change the order, right here m goes first inside. M actually goes from n to infinity. And then for the n, which is the red summation, it will go from 1 to infinity like this. And then this time we can work this inside out again. And again, right here, it stays the same. I already done was 1 over 2 to the m times 1 over 2 to the n. This is how you change the order of a double summation in this situation. It's so weird, huh? It's okay. Let me give you guys a quick explanation on this right here, alright? So, here is the deal. Let's look at this part first. We see that n goes from 1 to m. So let me put this down right here. N goes from 1 to m. So n is in between of 1 and m, right? And let me just put down the inequality like this. N goes from 1 to m. And again, we have to look at the inside and then out, right? Now, look at this right here. M goes from 1 to infinity. So m goes from 1. So if you look at the m part right here, m goes from 1 to infinity. So we have the infinity right here. So I'll put down the inequality like this. So as you can see, we pretty much have n goes from 1 to m, and then m goes from 1 to infinity. That's very nice. Now, if you look at this part, m goes from n to infinity. That's exactly what we put down. M goes from n to infinity. And then if you look at the n part, n goes from 1 to infinity. N goes from 1 to infinity. So that's pretty much it. And now the beauty of doing this is that we're dealing with infinite geometric series, which is a nicer formula, I would say. This right here, you can still work it out, but again, I will leave that to you. Anyway, to continue, as you can see inside here, we are in the m world. So we can put the 1 over 2 to the n to the front first. So this is going to be the sum. And then we have n goes from 1 to infinity. And this is 1 over 2 to the n's power. And let's look at this part, which is the sum as m goes from n to infinity. And then we have 1 over 2 to the n's power like that. And again, we should technically work out how this first. But this is just this times that, so we can just work this out first. So we see this is going to be the sum as n goes from 1 to infinity, and this is 1 over 2 to the nth power. Do not just do this part first. Do not just do the sum as n goes from 1 to infinity of 1 over 2 to the nth power and then get the value out of that. Don't do that. Because when you do this part, you are going to get an expression with n. Why? Because m goes from n to infinity. So be sure you work this out first, and then you get the expression right here that has some n involved, and then you deal with the 1 over 2 to the n as well, and then work things out. Anyway, this right here is a geometry series. The starting value is when m is equal to n. Remember, this right here of course converges because the common ratio is just 1/2. And you can just put the n right here into the m, and that will give you the first term. So we have the first term, which is 1 over 2 to the nth power. And then we divide it by 1 minus the common ratio, which is 1/2, like this. Anyway, we continue. Okay, I'll put down this right here. This is not an integral sign, so don't get too excited. This times that is 1 over 2 to the n times 1 over 2 to the n. So that's 1 over 4 to the n. So that's nice. And if you look at this part, this is like 1 over 1 minus 1/2. So if you look at just this part right here, this is 1/2 in the denominator. 1 divided by 1/2 is just 2. So we multiply by a 2 like that, right? So that's nice. And now, of course, you can put a 2 in the front if you would like. And this is, again, a geometry series that converges because the r in this case is just 1 over 4. So for this part, you put 1 in here, which is 1 over 4 to the first power, and divided by 1 minus 1 over 4 for the common ratio, like this. And of course, you can just work this out real quick. 2 times 1/2, 2 times, that's the answer. 2 times 1 over 4 is 1/2. Then you do this again, so this part right here, oh well, this is 1 over, this is 3 over 4, yeah? So you do the reciprocal, this part is going to give you 4 over 3. And of course, do your little fraction. All in all, you end up with 2/3 for the answer. Okay, so if you guys like the question that we just did, then I highly recommend you guys to check out Brilliant.work. In fact, I was just reading their summation by part page, which is so nice, just like integration by parts. So you guys can come here and check it out, and I'll have another video right here for you guys. But let me also tell you guys about their daily challenges, because it's full of interesting questions that you guys can work on. And because I have their premium subscription, I can get to the archives questions. And this is the question that I would like to show you guys. We have 4 people, A, B, C, D, and they are exchanging gifts. Everyone is going to bring one and leaves with a different one. Well, if D leaves with B's gift, then how many possible ways are there to distribute the rest of the gift? In fact, I have done a really similar video on this already, called the derangement. But if you guys haven't heard about that, be sure you guys come here and just think about this question. It's going to be really interesting. And if you are done, be sure you guys go here and you guys can continue learning. You guys can come here and sign up for a free account, so that way you guys can keep track of your progress. Or if you guys use the link brilliant.work/blackpenredpen, this way you guys can get 20% off discount, so you can get the premium subscription as well. Right, so this is how you can possibly compute a double summation in a nice way. And if you really want to work this inside out, just do it carefully, and especially when you have n goes from 1 to m, be sure you use the finite version of the geometry series. I think it's still possible, but I don't think the expression is going to be as nice as this right here. Anyway, hopefully you guys all like this video. If you do, please give me a like and subscribe. Thank you guys so much, and as always, that's it.